Advanced testing methods and reliability of electronics components, and this is a fraction or part 3 of our reliability concept we have started looking at from lecture number 6 and number 7. Today will be a continuation.
Together in my first lecture, the students will understand that or remember that we have discussed on classifications of causes of failure of electrical and electronic systems, where we make the presentation using this diagram. As you can see, the causes of failure of any electronics or electrical component is classified into two. The first one is environmental stress, and the second one is the operating stress. And I can remember that we, under the environmental stress, already discussed the atmospheric temperature, the heat effect and the remedy, the generated heat and its effect and the remedy, the humidity. We also talk about the mechanical shock and vibration. So now the remaining things include the atmospheric pressure, the wind, air and dust, the radiation and electrostatic effects. And we are also going to look at the operating stresses, which include voltage surge, current surge and frequency change. But as I have already said, we discussed mechanical vibrations, and we have seen the remedies, and these are the remedies we mentioned. We said there is need of using anti-vibration mountings, and the students, one of them, required that I should show them samples. Here are the diagrams, typical diagrams of what the anti-vibration mounts. You can see that at the two ends they are made of metallic substance, but in between we have a rubber, which when it experiences any mechanical compression, it will vibrate in such a way that it will absorb the effect without letting it propagate into the system where the component should be harmed. And also we set the second remedy for the effects of mechanical vibration is using shock-proof washers, and look at them here. You can see here they are made like springs, so they are tied together with the nuts. Whenever there is any mechanical shock, they will now absorb the loads by bouncing up and down, whereas the nut is already holding them tightly, so it prevents any much vibration. And the last or the next thing is the locking nuts, and you can see the diagrams here. These nuts are made in such a way that the moment they are tied, they lock themselves in place in such a way that no vibration will make them loose. So this is just a revision of what we have already seen before. Today we are going to continue from atmospheric pressure. The electronic components, when they are operated at a very high altitude in air, they are subjected to a very low pressure. Why? Because the formula for the pressure is given by rho GH, and rho is the density, which is constant. G is also acceleration due to gravity, which is constant. The only variable thing here is what? The height. So as you go higher from the ground upwards, you are reducing the overall height from the sky to the earth. And by reducing the height, you are reducing the total atmospheric pressure. And any electronic component that is subjected to this reduced pressure, it can have problems of what? Leaking of seals. Where there is sealing, it can break in such a way that things can go in and can come out. And typical components that are subjected to this kind of leaking involve the aluminum or paper foil electrolytic capacitors. So these capacitors, when they are operated at a very high altitude, they are subjected to low pressure, and the low pressure bring about the breakage of their sealing, and that causes their damage. And also whenever there is this decrease in the atmospheric pressure, we have decrease in the breaking voltage. That is the value of the voltage at which the problem can happen will now drop. If it was like 50, it can drop as small as 20, 25. Therefore, any small voltage that previously was not harmful can now be harmful, and it can cause the breakage of the insulation, which will damage the component. Now, what are the remedies to the problems of atmospheric pressure on electronics and electrical components? The first thing is to provide safe distances between electrical conductors. That is, we should make sure in those systems designed to operate at such altitudes, there is a given distance between one conductor and the next, and this will make it very safe for them not to experience any short circuit or to experience the flow of large currents as a result of reduction in the insulation resistance. And another thing is to make sure that we ensure dust-free and dirt-free path between the conductors. That is, we should make sure that dust or dirt does not accumulate between one conductor and the next, because if that happens, there is every tendency that those parts or these dirt parts, they can be moistened and they can serve as conductors connecting two parts that ideally not need to be connected. So the next thing is we are going to look at the effects of air impurities, and this includes the dust, include the dates, and it includes the sand, of course, even the salinity, that is the salty component in the air. Any equipment we know that is operated outdoor, it is inevitable for it to be exposed to these items, that is the dust, the dirt, the sand, the salinity of the air around the area where it is operating. The salinity is basically evident in the sea regions, because the seawater, we know it has large content of salt. So these dust in electrical or electronics components, they cause a trouble of tracking. What we mean by track is creating a connection, a path between one component and the next. And this component, if ideally they are not supposed to be connected, by connecting them, failure can happen. And also, the presence of dust in those electronic components, it reduces the insulation. Whenever the insulation increase, is reduced, the insulation resistance is also reducing. If you decrease the resistance, what happens is much current flow, and that much current can cause damage. And also the salinity of the air can cause corrosion because of its nature, and it can also degrade the insulation, and all these have effect of damaging the components. So how do we remedy these problems? The first thing is there is need of suitable sealing to make sure that we did not allow the dirt, the dust, the sand or salinity come in contact with electronic components. And if we do that sealing, it can also prevent them from being in contact with the salty atmosphere. And after this insulation, another way of remedying this problem is the periodic removal of the dust by blowing the components using blowers from time to time. That will reduce the risk of damage of the component. Also, among the environmental stresses, we have electromagnetic radiations, and we know the electromagnetic radiations include the alpha ray, the beta ray, the gamma ray, and all those radiations that exist in the atmosphere. And whenever they come in contact with the components, they cause malfunctioning of those components, especially if those components are bipolar solid states, like transistors. Also, the equipment that is designed to work for remote surveillance, that is, the ones that operate in deep spaces, they are existing in the pre-atmosphere, where these alpha rays, gamma rays, the beta rays, all of them exist. And also the devices that are used for controlling nuclear systems, they are exposed to this, because in any nuclear installation, we have alpha rays, beta rays, and all of them existing. So therefore, whenever you have a component, either for surveillance or for nuclear system control, it is exposed to them. And as we have seen, they can cause malfunctioning of the devices, especially if they are bipolar in nature. So, seeing the problems, what are the remedies? The first thing is shielding the component. By shielding, you are protecting it to make sure that there is isolation between where these radiations exist and where the component exists, so that they should not come in contact with one another. And another way of remedying this problem is careful selection of the components, so that the components selected, we know they have the strength, they have the ability of withstanding the effect of these radiations. If we do that, we are remedying the effect of electromagnetic radiations. The next thing is the effects of electrostatics. And as you know, electricity is of two types. We have the current electricity, the one we are using today, and we have static electricity, which was the original electricity discovered. And how was it produced? Whenever you rub two items, suitable items that are not conductors in nature, they will have the ability of creation the static electricity in such a way that one of them will lose electrons to the other, so that it has excess positive charge, and the other one that accepts the electron should be negatively in charge. So this static electricity, they have effect on most, that is metal oxide semiconductor devices. How does it destroy them? By destroying a thin layer of a silicon dioxide, which is deposited between the silicon and the metallization for the contacts. So what are the remedies to these problems? Because they do happen. The first thing is to eliminate the static electricity. How? By increasing the conductivity of the materials. I told you, the materials that has the ability of producing static electric charge, they should be insulators. So if you use your, the components that are most of them conductors in nature, automatically they will not produce static electricity, and that is safety for your system. Another way of remedying the problem of this is using electroconductive foams. These are foams just like a mattress, but they are able to conduct electricity. So whenever they come in contact with the static electricity, they will absorb it and conduct it away, so that the components are protected. And the last way we brought here is using electroconductive materials. They include carpets, which has the ability to conduct electricity. The shoes that can conduct electricity, they are suggested to be used by the workers who handle electronics components in the manufacturing environment, so that whenever they step on this carpet or they wear these shoes, definitely all the static electricity in their bodies will be discharged through those electroconductive carpets and the shoes, and therefore the component they are handling, they will be safe from any problem. We are done with the environmental stresses. Now we are going to look at the operating stresses, and by operating stresses we mean the stresses that exist in electronics and electrical components by the supply of energy to them. And this involves the voltage stress, the current stress, and the frequency stress, and we are going to discuss them one after the other. We start with voltage surges. The voltage surge occurs whenever you switch on a device. The voltage will go to a very high value above its normal value, and that is what we call the surge. And the maximum difference between that highest point and the normal, we call it peak overshoot. And this overshoot take place within a very short time, and we call the time the transient period. Yes, we know these overshoots, they are very for a very short time, but nevertheless they can be very high to a peak value that can damage the components if they are not taken care of. Okay, so how do we remedy it? To remedy this, all we need to do is to make sure that we put in place the devices, the components that have the ability of maintaining the supply voltage even below the rated voltage. Meaning, if supposing my system is designed to work with 220 volts, you can supply 180, 200 to it, so that you are making sure it did not even reach the maximum value to a place of going above. If that happens, it protects the device from the problem of voltage surges. The second item under the operating stress is the current stress. And these current surges is also that sudden increase in the value of currents beyond the maximum value, and when it happens, it can make the failure rate of the component to increase. And just like the effect of the voltage and the current fluctuation, that is change in the value of the current continuously when the system is operating, is also something that we must expect, because there is no way you can keep it steady, because if one problem did not cause it, another problem can cause it. So since we know it exists, how do we remedy it? To remedy it, we can compensate this by derating procedure. What we mean by derating is operating it below the rated voltage. If it is 1 amp, just supply something like 0.5, 0.7, so that you are safe from the sudden increase in the value of current. And this derating also is applicable to the voltage sources. So the last thing among the operating stresses is the frequency changes, and the operating frequency of the components whenever it is different from the designed one. For instance, if you design something to be operated at radio audio frequency, that's a very low frequency, let's say an amplifier, but you subject it to a very high frequency radio frequency, there is every tendency that amplifier will fail. What is the remedy? Make sure you operate the component within their designated frequency ranges. Now we are done with the sources of stress to component, which we divided into two, the environmental and the operating, and we have seen all of them and also discussed the remedy to the effect of each of them. So the next thing we are going to look at is what are the normal types of failures that happen to the electronics components. And we are starting with the fixed resistor, that is a resistor that has fixed value of resistance. This resistor is liable to some failures, and one of the failures is the decrease in the value of resistance. I told you, as you use it from time to time, the value of resistance decreases. We call this gradual failure, and it is a failure at the same time. Another kind of failure that is common to the fixed resistors is open circuitry, in such a way that it will not have connection between one point and another. Therefore, the resistance between the two terminals should be infinite, which makes the resistor useless. And there is another problem of increase in resistance. What brings about it are these items. Number one is the movements of the carbon under the influence of heat, or the influence of voltage, or the influence of moisture. What do we mean by the movement of carbon? Most of the resistors, the carbon-based resistors, they are produced using group 4 elements, which we know as what? Semiconductor. And these semiconductors, we know, depending on the concentration, the amount of voltage applied, the breakage of the bonds will increase with the increase of those things or reduce with it. So therefore, we use the conduction nature of what? The carbons to produce these carbon-based resistors. Whenever too much heat is applied, or too much voltage, or the moisture comes in contact with the resistor, it can cause the movement of the carbon. Also, the absorption of the moisture can cause the swelling, that is increase in the size of the resistor, and that can cause the separation of the carbon particles. Once they are separated from one another, the conductivity is reducing, and therefore the resistance of the carbon resistor will now increase beyond the designed value. And if it is in the wire-wound resistor, there are resistors that have wires inside them as the channel of what? The flow of current. The failure of this kind of resistor may be due to the breakage of the wire, or as a result of heat, or as a result of what? Corrosion. So these are the three types of failures that happen in fixed value resistor: increase in the resistor, decrease in the value of the resistor, or open circuits, and we have discussed the causes of all of them. The second component is variable resistor, that is a resistor whose value of resistance can be increased, can be decreased by what? Adjusting a control knob. And the common failures that happen in this kind of variable resistor, they are either open circuiting, or intermittent content. By intermittent content, we simply means that there is what? Constant opening and closing of the contact. When it opens, no flow. When it closes, there is flow, and you can see that that is a failure. What brings about that? The mechanical wear can cause that problem. Excessive current can also cause problem, because if current is too much, it will lead to the large flow of current, so that we have low resistance value. The item number 3 is the capacitor, and by capacitor here we mean the fixed value capacitors. What are the kind of failures common to them? The first failure can be open circuit, can be short circuit, can be intermittent content, and can be fluctuation in the value of the capacitance. How many? 4 of them. What causes all of them? Let us discuss. We start discussing on the intermittent open circuiting of the capacitor. What causes the open circuiting? Mechanical and the thermal shock. That is vibration from the mechanical energy, vibration from heat. They can cause damage of what? Open circuiting. The typical capacitors that are liable to this kind of failure, they are called paper foil capacitor. Then another cause of this open circuiting is the fracture of the connection, that is breakage of the connection, and it is common in ceramic capacitors. We also have the fracture of the internal connection, which causes open circuiting, and it is commonly happening in what? Electrolytic capacitors. Then we go to the second problem, which is short circuiting. The short circuiting is caused by either shock or vibration from mechanical energy. It can be caused from the leaking of the seal. That is, whenever a sealed area is broken, it can cause short circuiting. And what brings about the leaking is the mechanical energy or the thermal energy that cause the variation in the what? Pressure. Another problem we mentioned is the fluctuation in the value of what? The capacitance. And this fluctuation in the value is caused by either reduction in the dielectric value as a result of too much pressure. We know capacitor is designed with 2 plates. In between them we have a dielectric substance. So whenever the dielectric constant of that material reduces, it can cause fluctuation in the value of the capacitance. And also the fluctuation can be caused by thermal energy from mechanical, and this is commonly observed in aluminum electrolyte capacitors. Then we go to the component number 4, which is a variable capacitor. These variable capacitors, they are considered to be approximately failure-free. That is, they are very, very reliable. But that does not mean 100% they are not failing. Sometimes they experience failure as a result of air-space variable capacitors. If you have a variable capacitor in which we don't have a solid dielectric between the plates, but rather it is air that fills the spaces, we can have failure as a result of that. What brings about that? It can be as a result of loose of the plates. That is, the plates should be shaky. Once they are shaky as a result of mechanical energy, it can cause capacitor. And also, whenever that loose happens, the gap between the 2 plates should now be filled by the 2 capacitors, meaning the plates, they should be in contact with one another, and if that happens, then the capacitance is not in existence. And also another reason that causes problem in the variable capacitor is the deposit of dust or deposit of moisture between the plates. If we have air dates between them, dust between them, moisture between them, we can have a problem because the dielectricity between them is reducing, and therefore the overall value of the capacitance is also reducing. The component number 5 is inductors and the transponders. We place them into one because the inductors and the transponders operate on one principle, that is the principle of electromagnetic induction. Their failure can be due to open circuiting. It can be due to short circuiting of the coil. That is, if one turn of the wire come in contact with the frame, that is the core of the transformer or the core of the inductor, that is a failure. There is also a problem due to what overlapping of windings. Ideally, one winding is isolated electrically from the other one, because if you get a wire that we use for winding either an inductor or a transformer, use a razor to scratch on its surface, you see a leather material coming on, meaning they are insulated electrically. The only thing that brings about connection between one tone and the other is the magnetic field, not electrical energy. So when there is overlapping touching one another electrically, that is a failure. And mechanical damage is another cause of failure of the inductors and the transformers. So the item number 6, they are semiconductor devices, and these semiconductor devices, they experience a failure due to open circuit or due to what? Short circuit at the junction. And if you take a transistor, for instance, we have how many terminals? 3: collector, base, and what? Emitter. So there can be open circuit or short circuit between the base and emitter, between the base and collector, or between the collector and the emitter. And there is another failure that happened to these semiconductors due to environmental stresses like temperature and what? Humidity. And we can have failure of the semiconductor devices due to electrical interference. When two signals are operating in such a way that they are concurrent, that is, they have the same frequency and they are operating at the same time, there may be interference between them. So electrical interference do brings about failure in semiconductor devices. But one thing we should note is that most of the integrated circuits, they are damaged when the maximum supply voltage is exceeded. Supposing you have an IC that is supposed to be used by 12 volt, instead you use 18 volt or 24 volt, you can damage it. Another problem that damages the ICs is removing them or inserting them in the circuit when the power supply is applied. Before you insert it, you have to remove your source of power. Before you remove it, you have to remove your source of power. If not, a failure will happen. The item number 7 is the relay. And the failures that happen in the relay, they are due to corrosion of the wire. That is rusting of the wire. And if there is corrosion, we expect open circuiting because the contacts will break. And also the metal fatigue in the armature spring. That's the spring that attracts and releases the relay. When it experiences a problem of fatigue, that is, it is no longer working as a spring, that is a failure to the relay. Another problem that causes failure to the relay is the dirty contacts. If the contacts are dirty, that date can be conductive in nature, and it is now causing failure. And these dirty contacts, from where do we get them? They are mostly produced from chemical produced as a result of what? Sparking at the contacts of the relay. Now we are done with the basic electronics components and the major failures that happen to them and their causes. The next thing we're going to look at is the general approaches in reducing equipment or component failure. What are the steps, what are the stages do we follow in order to make sure that the rate of failure of component or equipment is reduced to the minimum possible? And there are different methods for doing that. The first method is having something to do with the part selection. That is, if you are going to select your component, you should be very careful. If you select the suitable component, the rate of failure is definitely going to reduce. And how do we select the component? First thing, we have to make sure the component we are selecting, they are very insensitive to the environment of their operation. That is, if you are operating them in the region where there is a very high rise in temperature, make sure they don't have thermal conductivity or thermal expansivity too much. And also you should make sure that the component you have selected, they don't produce any effect that can be harmful to their neighboring components in the same system, because they can damage them. You can also make sure that the components are protected. Either each individual component has its own protection, or you group them and protect them from environmental effects, temperature, pressure, humidity, and what have you. And also you should not change, you should make sure that they do not change in normal value outside their allowable tolerance limit. For instance, if you select a resistor of 10 kilo ohm and it has a tolerance of 10%, 10% of 10 kilo ohm is 1 kilo ohm, meaning it should have a value of up to 11 kilo ohm or as low as what? 9 kilo ohm. You should make sure that whenever the value of the resistance is changing, it should not go below 9 kilo ohm or above 11 kilo ohm, and that can be achieved if you properly select your components. Now, another method of improving or reducing the rate of failure is using improved construction methods and using new technology, and this involves encapsulation of the integrated circuit. That is, your integrated circuit, you encapsulate them, that is, you enclose them in such a way that you isolate them from the effects of environment as well as interference from other components. And another step of doing this is replacement of the relays, which are mechanical in nature, by what? Solid state devices that can be used for switching, just like relays. And also the integrated circuits can be used instead of using discrete components, because one IC can take hundreds of transistors, hundreds of capacitors and resistors. So if you have many components in discrete form, there's every tendency, if this one did not fail, the other one can fail. But if they're integrated into one IC, then you are reducing the rate of the failure. And finally, we are replacing the filament indicators. Those filament lights, they have been replaced by light emitting diodes in such a way that they don't have any conducting filament, that when it is broken, the indicators or the light have failed. These are light emitting diodes, they are solid state devices. Method number 3 of reducing the rate of failure is using redundancy. We have already discussed this one, and the redundancy can be active and can be what? Passive. We already discussed this one in our previous lecture. Method number 4 of reducing the rate of failure of items, components, devices is by using a technique called derating concept. What is derating? This derating is just a process of reduction of the operating voltage and operating temperature. If component is designed to operate as, let's say, 12 volts, you can take it as low as 9 so that you reduce the value of the voltage. If it can tolerate up to 60 degrees centigrade, maybe you can reduce it to 50. By reducing these values of resistance, voltage and the temperature, you are derating the parameters of the component, and you are reducing the stress on it. And the more you reduce the stress, the better the performance should be. Now, the formula we use for calculating the new failure rate when the derating is applied, we call it Arrhenius law, and it is given by this: lambda 2 equal to lambda 1 into V2 over V1 raised to power n k raised to power T2 minus T1, where this is my new failure rate, this is the original failure rate, this is my new voltage, and this is the original voltage, and this is a constant. This is another constant K, and T2 is my new temperature, and T1 is the original temperature. Now, let us illustrate this one using a worked example. We are given that the failure rate of a device is 0.00125 per hour. Then we are asked to determine the new failure rate when the operating voltage is derated to 2/3 of the original, and the operating temperature is derated from 60 degrees Celsius to 55. The constant N and K are given as 1.5 and 2 respectively. Now, the solution is my lambda 1 is given, my V2 is equal to 2V1 over 3 dash 2/3, and my N is given and K is given. Also, the two temperatures are given here. This is my T1, this is my T2. Substituting everything here, lambda. This is my V2 over V1. You can see this V's will cancel. I'll be left with 2 by 3 raised to power this. And here I have 55 minus 62 raised to power that. This will give me 0.4 zeros, 2 and 3. But the original is 2 zeros. You can see that it has been reduced by a factor of almost 70, 80 or of 100. So derating is one of the procedures of improving the lifespan of the components by reducing the rate of its failure. Now after that, the next thing we're going to see is the maintenance and the maintainability. You can remember, we already defined maintainability of a system as what? The probability that it can perform, it can be restored back to operation after failure, or it can be maintained in the normal operation with a good efficiency within a given time when the maintenance action is carried out according to some procedures. So what is maintenance then? The maintenance is the combination of any actions which are carried out in order to retain a device in its normal operation or to return it to its normal operation when a failure has already happened. What are the objectives of carrying out maintenance on any system? The objectives are, number one, to extend the useful life of the item. Yes, of course. Anything that you keep healthy, there is every tendency it will last longer. So by maintenance, we are prolonging the life of the device. Number two is increasing its availability, of course. Whenever you maintain something, you are making it ready to be used. Therefore, it is available. Number three is to ensure operational readiness of the equipment, particularly in the emergency situation. Whenever you are maintaining your system on daily basis or on a regular basis, there is every tendency when the emergency comes that you want to do it, you can with all hope go and use it without any fear because you maintain it. And another item that is an objective of the maintenance is to ensure safety of the people using the equipment, of course. If a device, if a machine, if an engine is not maintained properly, it will be very hazardous, it will be very dangerous to people using it. And of course, another objective of the maintenance exercise is to avoid high expenses when we allow the system to fail by itself. It will cost much because, as one proper saying is, stitch in time saves 9. If you have your cloth that tore, sew it, stitch it on that time. But if you leave it, the towing will be multiplied by 10. So doing it, it will reduce it to only 1. Now, the maintenance is also classified into different categories. Broadly, we have two. We have plant maintenance and we have unplanned maintenance. And this unplanned maintenance is the one that occurs in emergency situation. That is, we don't expect any failure, but the machine or the device failed, and that is emergency. We have to repair it. If we come to the plant one, it is of two types also. We have what we call preventive maintenance, and there is what we call corrective maintenance. Look at the words prevent. That is, we are maintaining the device before it fails. We are preventing it from what? The problem of failure. And this preventive is of two types. There is what we call running maintenance. We do it while the machine is in operation. That is, it involves the peripheral areas which does not require that machine has to be stopped. And we have shutdown maintenance, the ones that are inner. They are very strategic points in the machine or in the device, so that we have to stop the machine from operating before we maintain it. If you come to the corrective maintenance, it is the one in which the failure has already exhibited its symptoms, therefore we have to correct it before it degenerates into a very bad level. And how do we do that? It is of two types. We have a shutdown, the one that we stop the machine before it stopped itself and do the maintenance, and we have breakdown, the one the machine has already broke down and we have to do it. Now, what are the elements that are required for us to make sure the plant maintenance is executed successfully. The items are given here, 4 of them. The first thing, there is need of inventory, the list, the record of all the components that are to be maintained. Second thing is there must be a complete list of all the maintenance activities that will be conducted on those machines. And the third one is there must be calendar of event, that is the timing. In the first week we do this, in the second week, in the third week, in the last week, all this, that is the calendar. And also the last one is there will be a very effective method of monitoring all these items and making sure that they are executed when the time comes. So what are the benefits do we derive from plant maintenance? One of them is when you are doing plant maintenance, you have every tendency that there will be very insignificant failure rate in your machine. It will not be breaking down, because prevention is better than what? Cure. Another advantage is it is reduction the downtime. That is, it is reducing the time when the machine is not operating. Once you maintain it, you can keep on using it continuously. Another benefit of the plant maintenance is it is making the servicing very simpler and very cheaper. And finally, another advantage, it guarantees greater and more effective labor utilization. Yes, if you have your staff in the company, instead of keeping them doing nothing until a failure happens, you can engage them in doing routine maintenance so that you are utilizing them when the need arises. You are not making them redundant. Then, what are the methods of improving the maintainability of any system, equipment, or device? The first thing is provision of the maintenance checkpoints. That is an entry into the machine or into the device where the maintenance will be done. And this checkpoint, that entry, must be easily accessible. You can easily access it, and it should be hazard free. It should not be a point that produces dangerous gases, or it has sharp object that can cut, or any other hazardous situation. Another way of improving the maintainability is providing suitable tools and the test equipment. Yes, you cannot do anything if you don't have tools, if you don't have equipment to do that work successfully. Therefore, tools are very necessary. Another thing is provision of enough training to the maintenance personnel. You should be training your staff from time to time so that they will have the up-to-date knowledge on the problems of that your system and how to carry the maintenance operations. And there is need of provision of maintenance and repair manuals. Yes, you must have a guide manual that will guide your staff on different sections of the machine and different problems that can happen, and the suggested ways of carrying out the maintenance. Finally, there is need of enough adequate spare parts, because some of them that are already bad, you can replace them. Then we come to a segment where we are going to discuss some terminologies that are related to maintenance, related to maintainability. We have done this under reliability. The first term is called the mean time to repair. The mean time to repair of any device is the average time required to perform maintenance action. The mean time to repair can be developed. How do we estimate it? It can be developed at the design stage, because as we are going to see very soon, when you are designing your system, you do conduct some tests to give you idea on how to maintain it, what are the kind of failures and other related informations. So during the design stage, we can analyze maintenance tasks needed to correct the fault, and we can know the average time to do that. The typical sequence stages to be followed when carrying out maintenance tasks, they include what we call fault localization. The fault localization is a term standing for identifying the area where the fault has occurred. The next thing is called fault isolation. The fault isolation is after identifying where the fault occurs, you try to separate it from other parts so that it is on its own. Now, after localization and isolation, the next thing to do is correction. And for you to correct the fault, you do the removal of the component if it entails that, you do the replacement of the component if it requires that, you do the alignment, and then you do the check out to make sure that everything is done before you recouple your system. This mean time to repair MTTR is evaluated using this mathematical relation, that is summation of Ni lambda I Tmi all over summation of Ni lambda I. What is Ni? Is the total number of similar components we have in the machine, and the lambda I is the failure rate of those components, and the Tm is the estimated or predicted maintenance time in order to bring the machine back to its normal operation. So the next terminology related to maintainability is maintenance action rates, which is mu, or repair rate, which is mu. And what is this term? This is representing the number of maintenance actions that can be carried out on any particular item per hour, or average number of items or equipment which can be restored back to their normal operation afterwards they have failed within an hour. And this maintenance action rate is the reciprocal of the mean time to repair. Mu is equal to 1 over MTTR. The term number 3 that has to do with maintainability is maintenance time constraint. By constraint, we simply mean the limitation. Therefore, maintenance time constraint is the permissible repair time of an equipment. That is, what is the maximum time is allowed to make sure that the machine or the equipment or the device is repaired and brought back into its normal operation condition. Terminology number 4 that has to do with maintainability, they call it maintainability equation, and this is nothing but a mathematical formula that gives the relation for calculating the maintainability, and it is represented by m equal to 1 minus exponential minus mu Tm. We know this mu is the maintenance rate, and Tm is the estimated time for the maintenance action to be carried out. You can remember in the last slides we said this mu is 1 over MTTR. So if we substitute it here, we have minus Tm all over MTTR. For us to understand this one clearer, let us look at a worked example number 15, which says the average time to repair any fault in a given system is 1.5 hours. We are now asked to evaluate the maintainability of the system for the period of 3.5 hours. So here we can see that we are given the average time for the repair, and we are given the duration over which we are asked to repair. Now, the maintainability equation, as we know, it is equal to this. I'll now say my Tm is the predicted time that we are asked to carry out the maintenance, and it is standing for my Tm, and my 1.5 is what? My time to average time to repair, which is what? MTTR, that's mean time to repair. Substituting this, dividing this by this, taking the exponential, then 1 minus that will give you 0.903, which is 90.3 in percentage. So another term that has to do with maintainability is called utilization factor. And the utilization factor of any system or device, it is the ratio of the operating time, that's when the machine is operating normally, the maintenance time, the time during which the maintenance action is being conducted on the machine, and the idle time, it is the time period between the completion of the maintenance and the time when the machine is started for another use. So our utilization factor is equal to time of operation all over maintenance time plus idle time plus what? The time of operation. Another item that has to do with maintainability, we call it reliability. The reliability is the availability. The availability, we have already defined it while we were introducing the course. It is the probability that a system will perform its required function at the stated instant of time or over a period of what time. Now, let us go back to our utilization factor. If the idle time is equal to 0 and if the maintenance time is very small, so this utilization factor will have its maximum value, because you can see from the denominator my TM is minimum and my idle time has been eliminated because it goes to 0. Now, this is the new expression for my utilization factor, and in this condition we call that our utilization factor equal to our availability. Now, another thing that we can see is the time when the machine is operating, that's operation time, is equal to the mean time between repair, if you can remember your reliability. And the mean time to maintain is our MTTR, that is mean time to repair. Now, wherever I see TOP, I'll put MTBR, and TM, I will replace it by MTTR. Doing that, my availability is now equal to mean time between failure, all over mean time between failure plus the mean time to repair. For us to understand this one better, here we are going to take an example. Worked example number 16, an electrical generating set designed for continuous operation failed twice in the period of 123 days. The total time for repair during the periods is what? 3 days for the repair of the failures, 2 days. 2 failures. Determine the mean time between failure, the mean time to repair, and the availability of that generated set. Now, my total operating time is given as 123 days, but we are told that 3 days are used for the repair. So the operating time should be 123 minus 3, which is 120 days. And the total number of failures that happen within this period of 123 days is equivalent to 2 failures. Now, as you can remember, my mean time between failure is the total time of operation all over the number of failures that occur within that time. 120 over 2 should give me 60 days. Then the mean time to repair is equal to total time for repair all over total number of the failures. I am given 3 hours as the period for the repair, and I am given only 2 failures during the whole period. Therefore, I should have 3 over 2, which is 1.5 days. That's the average time to repair the generating set. And finally, I'm asked to calculate my availability, which is mean time between failure all over mean time between failure plus mean time to repair. This is 60 all over 60 plus 1.5. It will give me 97.6%. The next item that has relevance to these terminologies under maintainability is called unavailability. And this unavailability is just the complement of availability, meaning unavailability A cap is 1 minus A, which is the availability. And if you take the periods, the formula for the availability, which is this, and say 1 minus that and simplify, you finally get this as your formula for unavailability. So the next thing is there are testing methods that manufacturers use when manufacturing their products from the design stage up to the completion, and these are 3 in number. The first one is called prototype testing, the second one is called pre-production testing or qualification testing, and the last one is called production testing. Now, let us start looking at the first one, that is the prototype testing. First of all, what is a prototype? A prototype is a kind of sample of a device that is designed. Now you produce the prototype and examine it, test it, and see whether it is behaving according to the requirements of the engineering design. Now, this testing on the prototype is done before the design goes into the actual production. And when it is done, it helps us to detect any defect in the designed product. Is there any problem with the design? That prototype can reveal that. Also, if there is any shortcoming that is detected with respect to the performance of the prototype or with respect to any other parameter of that prototype, the design has to be modified. After modifying, new prototype will be produced and the test have to be repeated. The prototypes must be tested under correct environmental condition, because if you design something to operate, let's say, at a temperature of maximum 30 degrees Celsius, when testing your prototype, you test it in an environment with 100 degrees Celsius, definitely the result is not going to do justice to your design, because the environmental condition is entirely different from your design requirement. And if this prototype testing is going to be carried out, it has to be done by staff which is very competent. He has the skills to do it, and it is independent from the designers, because if the designer is allowed to test, he can just pass it believing that everything is okay. But if independent person takes your design, take the prototype and compare them, he can tell you these are some discrepancies he observes in your design. So when the prototype testing has been carried out, what are the errors that can be discovered, revealed? Number one, it can reveal design errors. And these design errors, they are those errors detected when the prototype has been produced according to the engineering drawing of that design, but it is not working correctly. Then we say that malfunction has to do with what? The design. It can also reveal manufacturing errors. That is where the prototype has not been made correctly according to the engineering design and drawings. So that kind of error is error during the manufacturing of the prototype, not with the design. And also it can reveal error number 3, which is parts fault. And how do we identify a fault as parts? It is where the individual components are found to be faulty when the prototype was designed. So if those components are the ones causing the malfunction, then we can say they are defective and therefore they have to be replaced and do the prototype again. That is prototype testing. The second one is called pre-production testing or qualification testing. And we do this testing in order to ensure the production of all the models have satisfied all the technical requirements stated in the engineering specifications of the design. And it is also done before the large number of production of the item have started, that is before the bulk production. And it is done by independent departments separate from the designers. Mostly it is done by quality control departments. It is done by quality control departments. And what are the kind of tests involved in this kind of pre-production testing? Number one, we carry out performance test to see how is the product working. We also carry out environmental test to see how environmental parameters like temperature affect the performance. We also carry out the reliability test to see the rate of failure of the device. We also carry out maintainability test to see how soon can we maintain it, can we restore it to operation when there is a failure. We also carry out packaging and transporting test. We put it in package, subjected to kind of pressure, or drop it to see how it is going to be. Is it going to be damaged? Is it going to be safe or not? we also carry out what we call physical test to visualize the shape of the device produced and see whether it satisfied all our requirements. So the last type of testing in the manufacturing process is called production testing. And we do this production testing to verify the conformity of the finished products with what? The specifications from the design. We also do this production test to investigate some reliability of the system and to determine the possible causes of the early or born-in failure. What are the causes of this kind of failures to the device? And also, at this stage, whenever we detect any failure at the production testing, that failure can be attributed to the component defect. That is, it is the problem from the component, not problem from the design, because the prototype testing, pre-production, they have already analyzed the design problems and handled them. And we can also attribute any failure at this stage to production methods. Now, there is what we call reliability demonstration, and there is what we call acceptance testing. This reliability demonstration is a test that a manufacturer of any product carry out in the presence of customers. He carries out this kind of reliability demonstration in order to convince them that the amount of reliability he said the product has, it really possesses it. And in a situation where the manufacturer did not carry out this reliability demonstration, the customer will carry untested products, take it to his place and carry out what? The test himself. And if he does that, we call it acceptance test. Meaning, if they pass his test, he is going to accept the component, but if they fail, he will return it to the manufacturer. Now, the next item we are going to look at is what they call accelerated live testing. We know the term acceleration stands for what? Increase in speed. So the accelerated live test is a kind of test that is done in order to reduce the very long time of the real life test. Maybe you want to test something for 3 years. How can you do that? So you have to subject it to a condition that if it passed that condition is equivalent to the test of that 3 years. And it is done using conditions which are higher than what? The normal. Because if you increase the level of the conditions, yes, you can reduce the time for testing. And when this accelerated live test is carried out properly, you find that the results obtained from it, they will correspond to the results that will be obtained in real life testing. And we have two types of this accelerated live test. Number one is a test which is carried out under normal condition, meaning your voltages, your current, your temperature, everything within their normal region. But if the device is expected to operate intermittently, that is, it will work for a very short time, stop, work for another short time, stop, now you subject it to continuous operation. Make sure it continues to operate without any stop. If it passed that test, within a given time, you can say, okay, even if it is extended to that very long time under normal condition, it will pass it. So in this one, we have normal supplies, normal environmental conditions, but the intermittent operations are changed into what? Continuous operation. The second type is where our normal conditions are intensified, meaning voltage level may be increased, current increased, maybe the temperature increased, humidity and all of them increased. But your operation, which is supposed to be intermittent, you leave it as it is, not continuous. But you have increased the conditions for voltages, for current and other environmental conditions. So this is what they call accelerated live testing, subjecting it to either continuous operation if it is supposed to be intermittent, or subjecting it to higher conditions, voltage, current, environmental temperature and what have you, and seeing the effects. So the next thing we are going to see is we have already demonstrated that there are two tests carried out, one by the manufacturer, which is demonstration test, and one by the consumer or the buyer, customer, and we call it acceptance test. In a situation where the components are tested and they were found faulty, they are now called rejected batches. And how do we treat them? What happened to them? These rejected batches can be the ones that could further be sorted, that is differentiated into different categories, or the ones that will be dumped unsorted. The ones that are dumped unsorted, they have two possibilities that will happen to them. One of them is you can make them scrap, that is, they are no longer useful, you put them as rubbish or sell them to other people at low prices, or you can send them back to the company so that we can process them again to make them qualitative. The sorted ones, they are categorized into two, because in the process of sorting you can find some that are not faulty at all, we call them effective items, and you can find those that are faulty, which are the defective items. And these defectives also, they have two types of conditions that may happen to them. One, they can be scrapped or sold at a reduced price, and they can be repaired or reprocessed depending on the situation they are in. Now the next thing we are going to see is the test characteristics of electrical and electronics components. If we see test characteristic of a device or a component, what do we mean? We simply mean the kind of results that we obtain when that component is subjected to those different tests. And the tests we have, there are many. We have tests that has to do with power supply failure. If there is failure in power supply, what happens? There is a test that has to do with power supply variation, that is if the voltage goes above or below, or the current, what happens? There is insulation resistance test to test the value of resistance. Is it up to the value designed for? Is it below? Is it above? To investigate that is what we call insulation resistance test. There is electrostatic discharge. That is, how is that device going to be affected by static electricity? And we have electromagnetic fields. How is that device going to be affected by magnetic fields in the area where it operates? And we have what they call conducted fast transient. If we say transient, is a kind of supply or condition that enters the component, but it lasts for a very short time, but it can go beyond the expected values. So we subject it to this test and see what happens. Is it going to fail? Is it going to pass the test? That is the characteristic in that nature. And also we have conducted high frequency interference. Whenever you operate your component in a place where there are high frequency devices operating, we investigate and see, is it going to malfunction? Is it going to fail? And also we have what we call conducted slow transient surges. That is sudden increase in the value of voltage or current, but at a very low frequency, that is slow transient. And we have conducted emissions, that is emission of the gases, radioactive the devices. How are they going to affect that your device? And the radiations emission from the enclosure parts, that is the casing where the component is. If there is a component that is emitting radiations, how is it going to affect the functionality, the operation of that system? Is it going to fail? Is it going to pass? That is the characteristic in that nature. And also, if you test the tolerance of your device or your system to salty environments, and also testing the vibrations from mechanical energy and testing the flammability. That is, if the temperature rises, is it going to catch fire? Is it going to inflame? If the voltage or current increase, is it going to inflame? Is it going to light and produce fire, or what? And we have inclination test. This one, you change the normal position of the device and see whether it will develop any fault or it will continue to normal operation. And finally, we have pressure test, to subject your device to a very high pressure and see whether it will malfunction or it will continue to operate normally. Now, the next item after seeing the test characteristic is designing for higher reliability. The main objective, what we want to achieve by designing products, is to meet the requirements under specified environmental conditions and to make sure that it doesn't have much failure rates. And how do we do that design that will reduce the failure rates and hence improve the reliability? The first thing is the component selection. Whenever you're doing this kind of design, you should select well-established components that are already known to be perfect. And if they are not available, you have to carry out analysis in order to select the right components. Second thing to do is considering the load-strength relationship. That is, if you know maybe your device can carry a voltage stress of up to 100, please make sure you operate it below 100, that's your load, so that it will have a longer life. Another thing is what they call minimum complexity. That is, if you are designing a system, once you want to reduce the failure rate and increase the reliability, make sure that device is kept as simple as possible. Because if it is complicated, so many components, so many segments, definitely if one did not fail, another one will. Then you look at what they call diversity. The diversity simply means develop a technique of avoiding common mode failures. That is, the failures that are known to you, they are occurring from time to time. You try to introduce a design that will avoid them. And item number 5 in the process of designing for high reliability is to analyze your modes of failure on each component and their effects. Knowing them will allow you to design a way of avoiding them. And the next thing is identifying single point failures. What you mean by single point failure? They are the kind of failures that keep on repeating from time to time. If you identify them, you have two options. You either try to mitigate them, that is to reduce them as much as possible, or to even design them out. That is, you substitute them with other things that will not be suffering that kind of failure. And lastly, you have to use lessons learned from the previous products, because you have already designed the system, you have seen its performance, you can know the kind of problems it experiences. So in your future design, you have to take those failures into consideration so that you reduce them and increase the reliability of the device. Now, what are the aims that we want to achieve by maximizing the reliability during the service life of a device? The first thing is, if you want to maximize your reliability, you have to be carrying different measurements to identify different problems and what produce different methods of handling them. And also, you have to control your manufacturing quality and your manufacturing process. If the process you are producing things is improved, there is every tendency you can attain maximum reliability. The next thing is to optimize your design. By optimization means to increase the level of certain thing and reduce some things in order to meet at a midpoint so that they will have a better performance. Build the process to improve the intrinsic, that is the internal reliability of your device, and also assure no systematic fault present in your products. What do we mean by systematic fault? That are faults that are associated with the way your system operates. If there is any fault that has to do with the system operation procedure, you have to find a way of avoiding it. And finally, the aim is to provide sufficient margin to meet the life requirement. What do we mean by margin? I will design something. In my design, I know it can be operated for 30 hours a day and 20 hours a day and no problem. But when I'm drafting the manual for that device, I'll write that it can be operated to maximum of 10 hours. If people keep on using it for 10 hours, they are not going to do what the maximum hours it can take, and therefore they are prolonging the life of that device. Now we are going to look at the process of packaging. That is, after you produce your product, you manufacture it, carried out all testing, there is another thing which is very important, that is packaging. How do you put them in proper packs for storage, for transportation, and other handlings? The packaging affects the reliability of item by either reducing it or facilitating the rate of failure. If you do good packaging, reliability increase, and if you didn't do good one, it reduces. The factors responsible for the failure during packaging, during transportation of the packed item, or during the storage of the packed items, they are three. One factor that brings about failure in either packing, either transporting, either storage, is inadequate or unsuitable packing materials for the transport or for the storage type. For instance, you have something that is very heavy. Instead of packing it in a metallic something or in a wood something that is very strong to hold, you just put it in something very soft. Definitely it can be subjected to failure. Another thing is the degradation, that is reduction in the quality of the materials you use for packaging due to the method of storage or before the use, because there are some things that can last for many years. For instance, if you put something in metal, the metal cannot be attacked by worm or any insect that destroy the wood. But if it is wood, it can be destroyed by those insects, and therefore you choose the right packaging material that can last longer if you are going to store the material for a long time. And another factor which is very important is inadequate of marking, that is pictorial representation of the instructions on how to handle the package. All of us have seen the package of different things, but we have most of the times not even pay attention to know what they mean. If you see this symbol of umbrella, you are saying that that device should not be allowed to be touched by water. It should be kept dry. If you see this symptom, it means you should keep it away from the heat, from solar radiation. If you see these two arrows pointing upward, it means the pack should be remained in that vertical direction. You should not lie it down, you should not turn it upside down. And if you look at something like this glass, it means it is very fragile. It is saying you should handle it with care, if not it can break. If you see something like this, it is showing you the direction in which you should tear to open the package. And if you see this sign of a hand, it is telling you that your device is very sensitive to electrostatic. Therefore, don't touch it with your hand. There may be static electricity in your body that can discharge and damage it. And if you see this symptom of thermometer, it is telling you the maximum temperature you should store it. And this arrow pointing down, it is showing the stocking limitation. What they mean by stocking limitation, how many other similar packs can you put on the top without causing trouble. So all these symptoms are very important. They have to be observed if we want to achieve higher reliability. So after seeing the packaging, we come to the issue of mounting, which is the installation of the material. The method of mounting or installing material can affect the reliability by either improving it or decreasing it, depending on how good you do it. When you mount your devices properly, the reliability is expected to be high. And also the accurate mounting, that is proper installation, is supposed to be explained in detail in the manual of the equipment. And the aspects that we have to observe whenever we are installing or mounting a system or device are given here. Number one is precision positioning, to make sure we accurately put it in the right position. Number two, we have to make sure we install it in such a way that it will be free from the problems of vibration. We have to use proper fittings, keys, nodes, washers, absorption of the vibration device, all of them, to make sure that it is properly installed. And we have to use coupling types and common problems. What we mean by this is, if you want to join one system and the other, if you didn't do it properly, there is every tendency operation of one can damage the other. And also the amount of torque, that is the holding force you are going to apply to that thing when you are fixing it or installing it, you have to make sure it is not too much and it is not below the minimum value. And finally, you have to do aligning and balancing. Alignment and balancing is a process of what? Trying to set and make sure it is in a perfect position so that it operates without problem. After looking at the issue of mounting in trying to improve the reliability, we come to the issue of cooling and ventilation. As we know, the heat is a byproduct of any electronic or electrical component, meaning whenever you're operating electronic system, electrical system, since current voltages are flowing, definitely heat is generated. That is the byproducts. But at the same time, it is enemy of electrical and electronics component, because if it is not properly dissipated, if it is not properly removed from that system, it is going to cause failure early in that operation of the system. And also the systems, as we know, they are packed in enclosures. Supposing you design an amplifier, you are not going to leave all your transistors, your IC open. No, use a metallic case to close them. That is your enclosure. So the enclosures, they serve two purposes. One is the protection, to make sure that those components, they are protected from the direct environmental effects. And the second purpose is the safety, because if they are not covered, you touch it with your hand, you can have a problem of what? Electric shock or any other problem. So the components in these enclosures, definitely they are subject to what? Damaging heat if the heat is not removed properly. And if they are damaged, definitely their lifespan will reduce and the reliability is also going to reduce. So if we believe that whenever electronics, electrical components is operating, it is inevitable for heat to be generated. How do we then handle the heat? The first method is to, what are the sources of the heat in the enclosures of electrical electronic systems? The first thing, they call it ambient temperature. By ambient temperature, they mean the atmospheric temperature. The second one is the solar load. That is for the systems which are located outdoor. The sun energy falling on them brings about rise in temperature. And the air that has high relative humidity, that is moisture content. You know, it is the heat that change the water molecules into a vapor, meaning it is that heat that is retaining them in vapor stage. When they entered a compartment, there is every tendency that the heat in the water vapor will go out and the moisture will now condense into the liquids. Another source of heat in electrical electronic systems is the operating heat because of the flow of current in the system. Now, these are the sources of generating heat, and we have seen that this heat, if it is not properly managed, it is going to reduce the reliability of any electrical or electronic system. Then what is the way out? The way out is to make sure that we provide different ways of cooling the enclosure of our system so that the heat inside is removed. How do we do that? We have three methods. Method number one is the natural ventilation. That is where adequate openings are provided on the enclosure in such a way that the air, cool air from the surrounding, will go into the enclosure and push away the hot air inside the enclosure. By doing that, you are reducing the temperature in your enclosure. The second method is using blowers or fans. The blowers or fans, they are electric motors that normally produces air that push out the heat inside the enclosure to the outside surrounding, thereby reducing the temperature in the enclosure. And the last one is what they call heat exchangers. These heat exchangers, they are a kind of closed system in such a way that there is no free air from the surrounding that will go and replace the hot air inside. No, but we have a closed system in such a way that the hot air is consumed into, let's say, a pipeline, and it is conducted to a region where it will be cooled, the heat extracted, then the same air will come back and carry the heat and keep on cycling like this. So these are the basic three methods of reducing and ventilating the enclosures where we have electrical or electronic systems. And if we do that, we reduce the effect of heat on our electrical and electronic systems. And ladies and gentlemen, I would like to thank you very much for your time, and this brought us to the end of this lecture. And of course, if you look at the course content, you see that the first segment of the lecture and this one, they have covered everything in our course outline. Of course, there are some things that are not in our course content, but I had to include them in order to make the course very rich and for the benefit of the students. So I thank you once again, and I want you to watch and watch again. It will definitely help you to understand better. Thank you very much.